All right, good evening, everybody. We're going to kick off with a quick video. Good evening, everybody. This is Hydra Strike, and we're going to kick it off with a bang with a quick video, all right? Maybe not. Or not. No, we're just trying to give the audience a little suspense here. All right, good evening, everybody. We are Hydra Strike. My name is Andrew Coyard, and prior to coming up here to do GSB, I spent 8 years defusing bombs in the Navy and spent a year over at Harpoon Ventures focused on our defense and dual-use portfolio. I'm joined here by Seth, who worked on eVTOLs over at Joby. He's a hardware engineer. I'm joined here as well by Gabriel, who worked over at NVIDIA on their AI chip development. Breno, who actually developed his own hydrofoil before he started this project. And then Alex, who is in computer science, has worked on a variety of projects throughout his time. So where we started, which we would have showed you on the first video that we'll show at the end of this presentation, is we tried to figure out a way to create a cheaper, heavyweight alternative torpedo. But after 110 interviews, 3 minimum viable products, and 1 strategic pivot, where we ended was providing a one-to-many capability to bring swarm technology to the maritime domain. And shout out to Commander O'Connor, who's in our audience, one of our sponsors, who's very gracious with his time throughout this project. Yeah.
United States Navy submarine commanders face critical decisions about which torpedoes to load into their submarines before deploying offshore. Storage space in the torpedo room is extremely limited, and reloading at sea or in theater is highly unlikely. Commanders must strategically select torpedoes from limited options, directly influencing their combat effectiveness. Currently, submarine commanders only have one option for the torpedoes they can have aboard. It's called the Mark 48 and is a highly sophisticated and capable system that comes at a sticker price of around $4.2 million. With the ability to target both surface vessels and submarines, this torpedo is a costly, specialized system designed 3 to 4 decades ago under a one-to-one engagement profile and very different than combat ranges. Today's maritime fight requires a completely different set of tools. Looking toward affordable and scalable weapon systems is the answer. After over 100 stakeholder interviews, 1 major pivot, and extensive research, we have developed an innovative solution to bridge this critical gap. Our solution is a submarine launch platform that brings swarm technology into the maritime domain. Deployable from submarines, UUVs, USVs, and surface ships, our solution delivers unprecedented range, reaching up to 160 kilometers at speeds close to 30 knots. It also integrates multi-layered communications and leverages multimodal sensing for a more accurate targeting system. Its modular top compartment can accommodate drones specifically configured to disable lower value targets, while the bottom compartment carries 3 small undersea kinetic effectors that commanders can independently guide to disable 3 separate targets simultaneously or coordinate together to neutralize a single high-value threat.
All right, so the first 4 weeks of this project was specifically dedicated to figure out why we need a cheaper torpedo in the first place. And to understand that, first we need to understand why we need torpedoes, why they got so expensive, and if we are going to create a cheaper one, how could we possibly do that? So first we had to understand why the Mark 48 advanced capability torpedo was developed. And it was developed to target one very specific submarine. It's called the Russian Alpha class. It went extremely fast, it dove really deep, so we built this amazing, capable, and exquisite platform in the early 1980s. But when the Soviet Union fell apart, we completely shelved the product. We stopped production in 1996. We fought 3 decades of counterterrorism over in the Middle East. And when we started production again in 2016, Lockheed Martin started with the prime contract, and as you can see, a variety of other vendors were producing different components. And it's not only that these components are very exquisite and highly capable, but it's also the fact that these independent vendors do all their own internal testing and validation. They send it to an intermediate activity. The intermediate activity does 5 full test shots, which includes complete disassembly, reassembly, testing and validation along the way, so that by the time it gets to its final customer, PMS 404, it's at a sticker price of $4.2 million a pop. But what we learned when we talked to our war gamers is that the world's changed since the Soviet Union fell apart. And if you believe that the Chinese hypersonic missile capability is going to push the carrier strike force potentially out of that weapon engagement zone, then the only capital asset that's going to make it to theater is our submarines, and they currently have one bullet, and it costs $4.2 million to fund. And the real problem with this is that the number of targets have vastly outnumbered our inventory. In fact, some war gamers think that we will run out of torpedoes in a single-digit amount of days. And to make matters worse, the Chinese shipbuilding capacity is 252 times the United States. This problem is not getting better anytime soon. So what we discovered is that the Navy stated they needed what's called Raptor, and this program of record and requirements are specifically designed to build a cheaper, heavyweight alternative at a sticker price of $500,000 or less. But as we looked and discovered of how we could possibly develop something like this, we had another key insight, and it turns out they actually stopped producing Mark 48 torpedoes altogether. And now what they're doing is just retrofitting old inventory with this advanced capability. So we had this amazing realization that maybe it's not the Mark 48 that's the problem. The core insights we have are, the current systems are designed for one-to-one effects. And as Joe Felter mentioned, with Operation Spiderweb, a couple of trucks with some drones can actually target and strike strategic assets. We're seeing something unprecedented develop over there in this world. Another key insight we had is a lot of competitors in the space building unmanned underwater vehicles with modular payloads with both sensors and kinetic effects. And the operational commanders need more options, especially given the high volume of target.
So at around week 4, we pivoted. We went from creating a Raptor torpedo, what the Navy said that they wanted, to creating a new capability, i.e. what the Navy actually needs. During the same time, 2 major announcements came out that completely reinforced the pivot that we made. First of all, the DIU solicited industry for super-sized undersea drones, as well as kinetic effectors to go along with them. This reinforced the idea that the Navy needed more operational flexibility and were willing to pay for it. At the same time, Anduril also unveils Copperhead, validating our move away from the Raptor program of record. So we went and created a first prototype, a buoy with a torpedo inside. A buoy with a torpedo inside. This basically would loiter in the sea and be able to expand the operational flexibility of our troops. We got as much feedback as possible and came to the realization that our initial solution doesn't actually solve the issue at hand. First of all, our initial system is still designed for one-to-one effects, i.e. one torpedo to one ship. Our second insight is that there's vulnerability to detection and attack with the buoy system floating at the surface. Finally, there was an unclear concept of operations or how this thing was actually going to be used in the first place. But the most important thing that we heard from everyone that we talked to was, how is it going to get there? So we went back to the drawing board.
Back to the drawing board, we felt a little bit like this guy. And what we really realized was the US's current solution is to build a small number of highly capable but highly expensive systems, when in reality, the war we are going to be fighting is a one-to-many war. Bottom line, if there are hundreds of ships in the strait, each system launched from a submarine needs to be able to target multiple targets, otherwise our defense is going to be completely outnumbered. So we went to part 3, one-to-many. Our second and current prototype is a system that is platform agnostic and can carry a range of different payloads, mission configurable to what operational commanders really need. The idea here is that with one system, we can affect multiple surface ships. However, after testing this idea with different submarine officers, we learned one major insight. They think that disabling ships is great, but they still need to be able to sink high-value targets. For brief context, this is how a current heavyweight torpedo works. It goes underneath, blows up, creates a large diameter gas bubble. When that gas bubble implodes, it creates a cavity at the surface, allowing the ship to fracture under its own weight, and finally, a high-velocity water jet shoots up through the middle of the ship, splitting it into 2. But if we were going to continue along our swarm multi-payload system, we were going to have to figure out how to create the same effect with a fraction of the total weight. So instead of creating one symmetrical large bubble, we decided, what if we combine multiple smaller payloads and arrange them in a way where you create a long elliptical bubble instead, creating the same effect but with a much smaller payload. Me and Breno then went to the Stanford Flow Physics and Computational Engineering Lab and literally just started knocking on doors. We eventually found someone who was interested in our problem and gracious enough to further help us. With them, we were able to complete hydrodynamic and computational fluid dynamic simulations of this problem and get a better understanding of how the coupled bubbles will actually work. Through this, we learned 3 big things. 1, the bubbles will converge underwater. 2, a cavity does form at the surface, creating that whole fracturing effect. And lastly, a high velocity water jet shoots up out of the surface, splitting the ship in 2.
So the reason why this validation matters a lot to us is because with this in mind, we can put in a single system and we can give it to decision makers and end users in the theater the possibility of either disabling 3 assets or a single very high asset with a single system. Now, next step was, can we actually fit this system inside a 21-inch torpedo tube? The answer is yes. The engineers of our teams pulled up our sleeves and got to work. We actually developed a mothership platform in which we thought about all the bill of materials and commercial off-the-shelf parts in which we truly believe we can rapidly scale. And we got to these numbers for the motherships. 160 kilometers of range at a cruise speed of 30 knots, and for the submunition we got to a range of 9 kilometers at a cruise speed of 30 knots. All getting you to $350,000 for a single system. Now, to put this into perspective, here's a map of the Taiwan Strait, and in scale is the range of the current Mark 48 AdCap torpedo of 55 kilometers. This is the range of our system. It's more than 3 times the range of the Mark 48 AdCap torpedo.
So we've been talking to our best interviewees about our new solution. They're very excited about the possibility of having swarm technology in submarines, and also that this is the first new weapon for submarine in almost 40 years. Yeah, this is our investment readiness level. I think we're at level 4 with this low fidelity MVP. There's still a long way ahead. And for the technology readiness level, we believe we're at level 3 with just this proof of concept right now.
Now, just to wrap up, we want to tell everyone we'll continue this project over the summer under the DIU Fellowship, and we're really grateful for this program. As well, we want to tell everyone who's maybe in Zoom over here, we're traveling to the Naval Underwater Warfare Center in Newport next week, so we'd appreciate if you want to introduce people over there for us, we'd be very good. Thank you very much.